So we have 3 rules for logarithmic rules. We're going to tie 2 of them into the exponential rule and show you how they're somewhat related to help you remember them. Look at some examples and do some of the problems. So if you guys just want to listen for a minute and then I'll give you time to write. First, use your product rule. If you go back to exponential rules, we would have, when we're multiplying, product means to multiply. M to the 4th times m to the 3rd, you would add exponents. The rule is the same for logarithms. If we have log of some base b, and we have m times n, then we can separate it and say that's log base b of m plus log base b of n. So just like exponential rule, multiplication is addition, and multiplication is addition. Go ahead and write. So looking at an example, let's say we have log base 3 of 7x. So 7 is being multiplied by x, so that would be log base 3 of 7 plus log base 3 of x. So again, we're multiplying 7 times x, so we are adding each individual logarithm. So the quotient rule, same idea. Again, I'll give you time to write. If we're dividing exponents, if we have m to the 10th power divided m to the 4th, that's an m to the 4th power, we would subtract exponents and get m to the 6th power. So the same is true with logs. If we have log base b of m divided by n, we would have log base b of m minus log base b of n. And for an example, if we have log base 3 of 7 divided by x, it would be log base 3 of 7 minus log base 3 of x. So again, product multiplying is addition, quotient division is subtraction. Power rule. We don't have a power rule for an exponential, so you can put an x through it, not applicable, whatever you want there. For logarithmic, if we have m to the n power, then the exponent, the rule is that the exponent comes out in front. Okay? So for an example, if we have log base b of x to the 5th power, we can take that exponent of 5, move it out in front, and we can go vice versa. Let's say I gave you this, and I wanted you to go back to that. Then you would take the 5, move it to the exponent, and go backwards. So now we're going to use, this is one type of problem. We're going to look at different types of problems that will come up so far. They'll get more complicated, but initially. One type of problem that we can see is where you're given that the log of some number equals some variable or some number. We're going to look at the first one where it's equal to a variable. So we're saying that the log base b of 3 is equal to g, and the log base b of 2 is equal to h. And so we're going to use those to simplify the following 4 problems. So looking at the first one, what you need to do is take what you're given and rewrite the problems based on what you're given. So we need to rewrite 6 using 3 and 2 because that's what we were given. So we can say that 6 is the same as 3 times 2. Then we have that multiplication is addition. So we can rewrite this as log base b of 3 plus log base b of 2. So now that we have it expanded, we can simplify it based on what we're given. Log base b of 3 is equal to g. Oops, I don't want the eraser. And log base b of 2 is equal to h. So we have g plus h. For the second one, we're rewriting 12. So 12 is 4 times 3, and 4 can be written as 2 squared. So we have log base b, 3 squared, or 2 squared times 3, 2 squared, plus log base b of 3. Then our power rule says that the 2 can come out in front. Then we can make the substitution. Log base b of 2 is h, log base b of 3 is g, so we have 2h plus g. Okay, next one, we have log base b, 3 divided by 2. So division, and it's already in 3 and 2, so we don't need to simplify it as far as like this, where we make 6, 3 times 2, etc. Division is subtraction, so that's log base b of 3 minus log base b of 2. Again, making your substitution. This equals g, this equals h, so we have g minus h. And the last one, 36. We need to write 36 in terms of 3 and 2 because that's what we were given. So 36 is 3 squared times 2 squared, right? 9 times 4. So again, we're going to use our rule of multiplication first. Log base b of 3 squared multiplied means plus log base b of 2 squared. Then we're going to use the power rule to have the exponent come out in front. Then we can make the substitution because now we have log base b of 3. So we can make that g and this h. So 2g plus 2h. So this is just one type of problem you can see where you need to make a substitution. You need to use the rules, expand it, make a substitution. If you look at the next page, the first one is similar to this, except that you're using a number. So now we have log base b of 5 equals this number, 1.367. We want to figure out a value of this. So what you're trying to do is look at what you're given that you have to find, 25. You have to somehow relate it to the 5. So obviously we can rewrite 25 as log base b of 5 squared. Using our power rule, the 2 comes out in front. Now we can substitute because now we have log base b of 5, which is 1.367. And multiply that by 2 and get 2.734. For the next one, so this is going backwards. We started with, like here, we started with 5 squared and we expanded this out like we did on the other problems. In this case, it's already expanded and we're going to go back and make it, pull it back together, okay? So you're going to use the rules backwards in a sense. So first thing we notice is the 1/2 is out in front. That's an exponent, so it's going to come back as an exponent. Plus is multiplication, minus is division. So I have log base b of p. Plus means times, so times t. Minus means division of q, and it's to the 1/2 is out in front, which moves to the exponent, so the 1/2 power. The question's asking you to write x in terms of these numbers. So basically what it's saying is we have log base b, so therefore if those are the same, then x must be equal to pt divided by q to the 1/2 power. In the next question, we are expanding. Okay. So now it's saying, it's kind of like this. We're starting here, we're going to go back to this. So here we are, we have m squared n divided by p square root of s. Now we want to write it as log base b of x. So basically, if I take the log of this side, I'm going to take the log of the other side. So that's acceptable to take the log of both sides. Then I'm going to use the rules. Here I'm going to do it, take the square root and write that as 1/2 power. So it says square root, I'm going to write it as a power. Now I'm going to use the rules to expand. Multiplication is addition. Division is subtraction. So what you have to do is be very careful. Some people will argue that it's p times s to the 1/2 power, so I should have plus. But plus indicates multiplication, meaning that this would then be in the numerator. So even though p and s to the 1/2 power are being multiplied by each other, they're both being divided. So you could put a minus a parenthesis, or just think that if it's in the denominator, it's division, so we're subtracting. Then to finish the problem, we have to use the power rule and bring your exponents out in front. So the 2 goes in front. And the 1/2 goes in front. For the last one, we're going to use the rules again to solve for x. So we have a plus here, which means to multiply. So we have 4x times x. Since both sides have log base 4, then we can set this part equal to this part. So we have 4x squared equals 64. Divide by 4 and take the square root. Now, go back to yesterday where we talked about what does the graph look like and what does the domain look like. So this is a basic log function. We talked about that the domain is x is greater than or equal to, no, it couldn't be equal to, just greater than 0. So we can't take the log of negative numbers or of 0. So when we solve something, we have to go back and look at the original problem. It's not the -4 that makes it so that we can't use the negative number. It's taking the log of a negative number. If I go back and put -4 in here, I would be taking the log of -16 and -4. And that's why -4 doesn't work. But if I had had something like this, hadn't been 4x, let's say it had been log base 4 of -4x, okay? Then I got an answer of +4. If I put +4 in here, I get -16. I can't take the log of a negative number. So you're not looking at whether your answer after you do the algebra is positive or negative. You're looking to see that if that answer, once I plug it back into the original, causes me to take the log of a negative number or 0. And if it does, it's not a solution. So even if it works for like one part, let's say it worked for this, but it didn't work for this, if it doesn't work for one part, then it's not a solution and you can't use that as an answer. So our only answer for this one is x equals 4.
Bye. Did you hear that?
Bye, Kentucky people. Want to say bye to the Kentucky people?
Bye.